In this video, I'm going to be talking about computer hardware architecture. So, as a software engineer, it's important for you to understand hardware architecture for a computer because you need to know which part or which component to the hardware level is responsible for translating commands into binary and how exactly execution happens on the hardware level of a computer. Okay, so before you come to this diagram here, the architecture itself, I need you to focus on these words below here. Okay. So what exactly is computer architecture? The computer architecture is made up of four major components. One, there should be inputs. There should be data that comes as input into a computer. When that data comes, two, there should be some sort of processing. After the processing, there should be storage of that data that is processed. Or if it is not stored, it will be what? It will be output. Somewhere, maybe into a flash drive, onto the cloud, or output maybe into a disk. Anyway, it will be output somewhere, but the point is that there will be output. Okay. So if you have a computer like this, you have your laptop. Okay, you want to play your movie. Okay. So on this laptop, there has to be input of information of data. So it could be that you are streaming maybe on YouTube or any other streaming platform. That streaming platform will be the source of that information. That will be where the input is coming from. The processing will be done by a computer where you start watching now. And then the output will be what you are seeing as well. Okay. So for a computer to do anything, there must be information that is input. There should be processing. There should be storage. There should be an output. Okay. So this is how the architecture is of the main components of a computer. So the key on the most significant component in a computer is the CPU, or the central processing unit. So the central processing unit is the one that does all the processing, converting code into binary, any form of instructions that have to be run and performed. They're performed in what? They're performed in the central processing unit. So the central processing unit is surrounded by two main components, okay? Two gates, okay? There's one that they call the south gate. The south gate is where now input comes from. So the south gate is connected to peripheral devices. So these are the ports that you have in a computer where you can insert an HDMI cable, the port where you can insert a flash drive, the port where you can insert an external hard drive. That information comes from all those outputs here. Maybe a hard drive here, okay? Maybe a flash drive here. Maybe you have a disk here, or whatever input that you want, but the information is coming from outside the computer. So when that information comes, it doesn't go directly straight into the CPU. It runs through this gate here. It's called the south gate. And then this path in black, this is known as a bus. So all the cables that interconnect these computers are known as what? They're known as buses. Okay, so buses just transport information from one computer to another, from one component to another component in a computer hardware system. Okay, then that information comes to the CPU. So in the south gate, the north gate connects the central processing unit to memory elements. So this is where memory is. So you have the registers, you have cache memory, and also you have random access memory. So the north gate links the CPU to what? To memory elements, and then the south gate links the CPU to what? To input. So this is where input is going to be coming from here. Okay. And processing is going to be done by the central processing unit there. And then storage will be done by the memory elements here. Okay. And then, so registers are temporarily high speed storage blocks of memory. So here you store small sized information, but information is stored, they store information, it's temporary information, and then they're very fast. In case you need this information to go to the output, when they're coming from registers, they're going to be much more faster than when they're coming maybe from another storage this side. Okay, this from here, transferring information from here to there is going to be faster than transferring information from here up to the output there. Okay, so same thing with cache. Cache is also fast. Registers are faster. Cache. Then you have random access memory, where the way the random access memory is going to function is that, let's say you have two programs that are open. Program A, okay, let me write from here, program A and program B. Let's say they're open. So in program A is actively being processed, okay? This one is going to be on pause. So this is where you have a program that is, you are actually working on, or let's say you have a VLC player open, okay? When it's open and you're playing a movie, it's going to be in the CPU. to be running from the CPU. In the moment that other program that you have, let's say you're working on a document, the moment you suspend that program, if it was in the CPU, it's going to be brought in the RAM. Okay, so the RAM here is just going to be stored suspended programs. And then there's a program called the scheduler. The scheduler is the one which determines which program to pull from the RAM and to put into the into the CPU. So programs will be stored somewhere in secondary memory. Okay, so here there'll be secondary memory, so you can have a hard drive here. Okay, it's also a memory element. Programs are put from the hard drive, they are put into RAM, then from RAM they're taken into the central processing unit. So this marks these are the major components you should be aware of on the architecture for the hardware architecture of the computer. So there has to be input, there has to be processing, and there has to be there must be an output. So you have inputs, you have processing, you have storage, and then you have output. So this is how the architecture of the computer actually looks: input, CPU, output, and memory. Okay, maybe the summarized architecture will look like this: CPU, input, output, and also memory elements. Okay.